Hello, my dear warriors. Welcome to the next session of your JEE Mains 2024 PYQs. And today's topic is ray optics. And this series basically covers all the PYQs from 2024, which is a must do for all the aspirants of 2025, 2026. So these lecture series are brought to you just exactly for your practice purposes. So pause the video at any point of time where you think that you want to solve on your own, take hints from the solution, and maybe the solutions are way different than what you thought to be. All right, so this is your Captain Shreyas, your physics master teacher. Get ready for the next amazing session, and do not be selfish. Quickly smash the like button because we are putting in a lot of efforts in recording these videos. Show your support for the Vedantu J English channel. Be a part of it. Make sure you are subscribed so that you do not miss any other classes that we are going to discuss. All right, so it's time to start the session. Thank you for liking. Thank you for subscribing. Here is the first question on your screen. Ray diagram is given. Lenses are given. Question is, what is the distance between lens 1 and 2? Well, kind of very simple. If this ray is going to meet over here, is going to go over here, this will be obviously the focal point of the first lens. This ray, if I change the arrow mark's direction by reversibility principle of light, it must pass through the focal point of the second lens. That means this is focal length of the first lens, which is already given to be 10, and this is the focal length of the next lens, which is already given to be 15. So the total distance between the lenses will be 10 plus 15, which is 25 centimeters. Very simple. Simple question based on the ray tracing and reversibility of light. Next question. Statement based. When an object is placed at the center of curvature of a concave lens, image is formed at the center of curvature of the lens on the other side. This doesn't make sense because this is not entirely true, and it is not even necessary. See, if you have a lens, right? First of all, what is the guarantee the radius of curvature will be equal? It is not even given, number one. Number two, uh, where the image is formed not only depends on the radius, but also depends on the refractive index. So the same ray might go here, or might go here, or might go here, because mu can be different, So it depends on the refractive index. Nothing is mentioned about it. So it is wrong to say it will always go meet somewhere. So statement one is wrong. Concave lens always forms a virtual erect image. Well, that is true. So if you have a concave lens and if there is an object over here, the image is erect, right? It is virtual. Definitely this statement is correct. We see that whenever we see objects through a concave lens, the image becomes small and it is virtual in nature. Convex lens is your magnifying glass, which magnifies it. So statement 1 is false, statement 2 is correct. That was your statement based question. Three lenses are there, combination is there. Where is the final image formed? Now, a lot of people think in this particular question, what we can do is combine the lenses, using lens maker formula. Combine the lenses using combination of lenses formula. But that is not correct because the lenses are not in contact. So you cannot combine it as 1 by f1 plus 1 by f2 plus 1 by f3. There is some gap between them. So whenever there is a gap, you have no other choice but to use lens formula. So if you use the first lens formula, 1 by v1 minus 1 by u1 is equal to 1 by f1. 1 by f is basically plus 10 because it's convex. v1 I don't know, object distance is minus 30. So 1 by v1 will be 1 by 10 minus minus plus. On the other side it will again become minus. So LCM is 30. So 3 times minus 1. So it will be 2 by 30, which is 1 by 15, which means V1 is plus 15 centimeters. So from here 15 centimeters, this is 5, this is 10, so somewhere here. So the image is formed here. This is the image formed over here. That means the rays from this particular object, the rays which will come from this particular object will go and meet over here, will go and make that image over here. Now, actually, if you think about it, the focal length of the concave lens is also 10 centimeters. And this is purely coincidental. Because of that, what happens? Any ray which is directed to the focal point of a lens will become parallel after refraction. What will it happen? It will just become parallel after refraction. Oh, perfect. If it becomes parallel and it is incident on the third lens, it should pass through the focal point of that third lens. Where is that focal point going to be? At a distance of 30 centimeters. So the final image will be formed at a distance of 30 centimeters from the third lens. That is the correct answer. So actually we did not use lens formula 3 times. That is just because of coincidence, where we saw that the image was formed here, which actually becomes the object for this lens. And since we know the rules of ray tracing, you should know it. You cannot say, sir, I studied that in 10th standard. A ray which is incident on the focus will become parallel after refraction. That's the logic or ideology behind this question. Moving on to the next one. Critical angle of incidence is 45. Refractive indices are in the ratio. Okay. Critical angle formula is sine of critical angle is 1 by refractive index. Critical angle is given to be 45 degree. Mu, I don't know. Sine 45 is 1 by root 2. Take reciprocal both sides. So root 2 goes on the top, mu also goes on the top. So mu is root 2. That means if I take the first medium, which is the dense medium, refractive index is root 2. Then it goes to the rare medium. The refractive index of air is 1. So the ratio will be root 2 is to 1. That is option number D. Cool. First medium is dense. Second medium is rare because we are talking about, internal reflection and that phenomena. So internal reflection happens when the light goes from dense to the rare medium. Moving on to the next question coming up on your screen. For a thin convex lens, the radius of curvature are 15 and 30. The focal length is 20. The refractive index is. I believe this is a question on lens maker formula. Correct. So 1 by f is equal to mu minus 1. 1 by r1 minus 1 by r2. What is the focal length? That is given to be 20. What is the refractive index? That's what we have to find. What is R1? Well, that is 15. What is R2? Well, that is 30, but don't put 30, it is minus 30. If you're wondering why, well, think about it. For what is this? Convex lens. This is the first surface. The radius will be like this. The center of curvature 1 will be like this. The second surface will be like this. The radius will be this one. This would be the center of curvature. Okay, so understand, this is the negative side, this is the positive side. So C1, that means R1 is positive, C2, that means R2 is negative. That's all. So a lot of people make a mistake here. So this will become mu minus 1. Minus minus is plus, LCM is 30, so it will become 2 plus 1. Okay, 2 plus 1 is 3. So 3 divided by 30, that's 1 by 10, that's 1 by 20, 0, 0 cancels. Take 1 on the other side. So mu is equal to 1 plus 1 by 2, which means it is 3 by 2, which means it is 1.5, which is option B. Perfect. So this was the only tricky part. Apart from that, rest was simple algebra. Nothing great about it. Okay. So be careful about the sign convention, especially in ray optics. Moving on, next question. 5 lenses in contact, total power 25. What is the focal length of each? Here, when lenses are in contact, we can just add the powers or reciprocals of focal length. So 5 lenses, each having power P1 or PL, is having a total power of 25 diopters. So the power of each lens is 5 diopters. But the power formula of any lens is given by 1 by focal length of the lens. So therefore, the focal length is 1 by 5 meters, because diopters is SI unit, meter is also SI unit. Converted into centimeters by multiplying by 100, which is basically 20 centimeters, which is B for IT Bombay. Very simple and sweet question, right? Everybody would crave or hope that we get such a question in the examination. Wow. So here errors in the object and the image distance is given. Focal length is measured using some object distance, image distance, and if each of them have some error, there will be some error in the focal length. You might argue this is a question also from units, dimensions and errors. Nevertheless, we can still solve it. So you cannot use any standard formulas because this is not simple addition, multiplication, division. See, for half mv square, time period is 2 pi root L by G, you can do that. But this is reciprocal. So you need to go from the basics. And the basics says that you write the formula and differentiate it. That's how you get the errors. So our basic formula of what is this? This is a length. So 1 by V minus 1 by U is basically 1 by F. Write it on the top. So V raised to minus 1 minus U raised to minus 1 is equal to F raised to minus 1. Now what you do is basically differentiate both sides with respect to any variable, doesn't matter, x, y, z, t, whatever. But you can't differentiate it directly. So you'll have to use chain rule, remember that. Okay, v can't be differentiated with time. So derivative of v raised to minus 1 by dv into dv again by dt over here minus du raised to minus 1 by du using chain rule into du by dt is equal to df raised to minus 1 by df into df by dt. Now v raised to minus 1's derivative is minus 1 into v raised to minus 2 into dv by dt minus this guy's derivative is minus 1 u raised to minus 2. This is x raised to n's formula, which is nx raised to n minus 1 into du by dt is equal to minus 1 into f raised to minus 2 into df by dt. A lot of things will get cancelled like dt, 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 minus 1, minus 1, minus 1. And obviously nobody likes to keep things on the top with a negative power, will immediately shift it downwards. So v raised to minus 2 will become 1 by v square. So dv by v square minus du by u square is equal to df is equal to df by f square. Now dv is a small change in image distance, small change in object distance. This is small change in focal length, which is also errors. So might as well write it as plus minus delta v by v square minus plus minus delta u by u square is equal to plus minus delta f by f square. Now here is the catch. Whenever you write minus of plus minus, understand, minus of plus minus is plus of minus plus. Now plus of minus plus will again be same as a plus of plus minus, because whether you do plus first or minus first here does not matter. We are looking for the maximum possibility of error. So the maximum error which will be possible will be when this is plus and these both are minus. So you will get this value added with this value, which will give you the maximum possible error in it. Understand that. So technically speaking, this will be same as delta v by v square plus minus. Instead of minus of plus minus, you can put it as plus of minus plus, which is same as, instead of putting plus of minus plus, you can just put it as plus minus over here. Delta u by u square is equal to plus minus delta f by f square. Now shift this f square on this side. So you will basically get delta f is equal to f square into this whole thing, which is option C. Yes, it is, which is option C. Perfect. A brilliant question. It involves derivatives and chain rule. So this is the actual way in which errors are determined in case any of the standard rules or formulas are not applicable. Use derivatives, not anything else. Okay, cool. This is one of the best questions. Right. Moving on. This was asked in 2 shifts. The question is find the minimum deviation angle if the refractive index is given. Refractive index, angle of prism, minimum deviation. There is only one formula, which is mu is equal to sine of A plus delta minimum by 2 upon sine of A by 2. Now this mu is already mentioned to me that it is, listen, it is cot of A by 2. Now what is cot of A by 2? It is basically cos divided by sine. Perfect. And on the right hand side, we still have this whole thing, which is sine of A plus delta minimum by 2 upon sine of a by 2. What happens brilliantly is that sine of a by 2 and sine of a by 2 just got cancelled, right? Sine of a by 2 and sine of a by 2 just got cancelled. So we have cos of a by 2 is equal to sine of a plus delta m by 2. But you know what? I don't like to compare cos with sine. I will compare apple with apple, orange with orange. So cos, I can write it as sine. Cos theta is sine of 90 minus theta. So I can write it as sine of 90 minus a by 2, right? And this thing is as it is, which is sine of a plus delta m divided by 2. Now I can compare the inside thing. So inside terms will be equal. But here, before going ahead, I will obviously take the LCM. So the LCM will be 2. So 180 minus A, the whole thing divided by 2. Of course, again, we can cancel this 2 and this 2 over here. So now take the same on the other side. So this will become 180 minus A is equal to delta M. So delta M is 180 minus 2A, which is this or even this. This was asked in two different shifts, once in degrees, once in radians. So it doesn't matter, it was the same thing. That means you got lucky if you got the same question in the next shift. So you can see that in the same year, same question can get repeated. In fact, the pattern also gets repeated. You will see so many of the questions were very similar looking, like ray tracing, so many questions were there. This got repeated. Also, you will see magnification, image distance, object distance, questions got repeated so many times. All right. So that means you need to be attentive. You need to keep an eye on the pattern models of questions, whatever is being asked. Distance between object and its 2 times magnified virtual image produced by a mirror is 15. The focal length must be how much? Okay. First of all, the magnified image means the magnification is 2 times. It's a mirror. It's a mirror. All right. The magnification formula is nothing but minus V by U. Minus V by U. That is the formula. Now, because it is a virtual image, right, and it is magnified 2 times, okay, so the magnification must be positive or should it be negative? Just think about it. Should it be positive or should it be negative? Just think about it. If it is virtual, okay, then the image is formed basically behind the mirror. Image is found basically behind the mirror. So the image will be virtual and it will be having positive magnification. Just like take the example of this particular mirror over here. Imagine this object was there over here, okay, and it formed a virtual image over here. This is the virtual side. Imagine this is the virtual side behind. So the image is erect. So the magnification is positive because of this positive magnification. So this minus V by U value should be basically plus 2. That's what I will say. Rather, I can also say V is basically minus 2 times of U. And one more thing, it is given that the distance between object and its image is 15. Remember, although we use V and U as distances, actually they are not distances, they are coordinates. And when I ask you the distance between the two coordinates, what do? You subtract the two coordinates. That's all. So basically, the image coordinate and object coordinate, if you subtract, what you will get is the distance between them, which in this case is 15. But V is minus 2U. V is basically minus 2U, right? Everybody? Till this point? Okay. So what will you get? Minus 2U minus U is basically 15. Therefore, minus 3U is basically 15. Therefore, U is basically minus 5 centimeters. But V is negative of 2U. So from this, we'll get V is minus 2 times of minus 5, which means it is plus 10 centimeters. From this, we can find the focal length. So 1 by V plus, because this is a mirror, 1 by u is equal to 1 by f. V is basically 10. U is basically negative 5 is equal to 1 by f. LCM is 10. 1 minus 2 is equal to 1 by f, which is minus 1 by 10 is equal to 1 by f. That means f is equal to negative 10, which is option A. Yep, that is the correct answer. Okay, so you just need to be careful with the signs and the positive negativeness. You should know if it is virtual image or erect image or diminished image or you know a real image, what happens to each sign of either object distance or magnification. That's all. So if you are aware of how the images work and if you have been practicing ray tracing, it becomes easy. All right. This is done. Okay, moving to the next one. The radius of curvature is 30. Image is half the size. Okay, the object distance is how much? That is the question. So if the radius is 30, the focal length will be radius by 2, which is 15, and it is convex, so it should be positive. Perfect. So focal length is 15 centimeter. Next is the image is half the size. That means the magnification is half, and since it is clearly mentioned it is a convex mirror, it must be positive. So this is basically positive half. The formula for magnification for a mirror is negative V by U. So that is half. Therefore, I can say V is basically negative U by 2. Perfect. Now let's go to the, what is it, mirror formula. So 1 by V plus 1 by U is equal to 1 by F. V is negative U by 2, negative U divided by 2. Plus 1 by U is equal to 1 by F. Now this is 1 minus 2 divided by U is equal to 1 by F, which is negative 1 by U is equal to 1 by F. So U is equal to negative F. That means it is negative of 15 centimeters, which is option number B. Just check this out. Yes, it is the correct answer. F was directly mentioned, or rather we found it out from here. So that's how we substituted it. Is that okay, everyone? Clear till this point, I hope. Awesome. Awesome. Moving on to the next question coming up on your screen. A biconvex lens has focal length in air. What is it when in some other liquid? This is also a very standard question. Use lens maker formula twice. First time the focal length is 20, which is refractive index, which is 1.5 minus 1 into 1 by radius 1 minus 1 by radius 2. Second time, the focal length is unknown. Refractive index will be now relative. So relative is mu2 by mu1. Mu2 is 1.5, which is of the lens. Refractive index of the liquid is 1.6, so minus 1. So 1 by R1 minus 1 by R2. Obviously, the next step is to divide both of them. The moment you divide 1 by 20 with 1 by F2, F2 will go on the top, 20 will be here. This and this will get cancelled. So 1.5 minus 1, this is 15 by 16 minus 1. So that is 0.5 divided by minus 1 by 16. So I can further simplify it as F2 divided or F2 is equal to 20 multiplied by 0.5 divided by a minus 1, and that goes multiplied by 16 over here. 20 into 0.5 is 10. So 10 into 16 divided by negative 1, which is minus 160. So that is option number D. So you need to be very careful because both the options are given plus 160 and negative 160. If you make any simple mistake anywhere, that's it, gone. You will get a completely different answer. So be very careful with science, and you need a lot of confidence to mark anything, especially when the answers are confusing and the options are given in such a way that if you make a mistake also you get one of the options correct. Moving on. Now this question, like you can see, is asking about spherometer's use. So spherometer, just like it says, the name says, it is used to measure a characteristic of a sphere or spherical object. Basically, it is used to measure the thickness, the radius of curvature of, any lens or a curved surface. So yes, it can be used to measure radius of curvature of a concave or even convex surface, thickness, yes. Specific rotation, no. It cannot, remember, it cannot be used for rotation. Specific rotation doesn't make sense. Yeah, it is. It was a very weird question which was asked in the shifts, and many people thought that something is wrong, but nothing was wrong. Look at this question. I can see photoelectric effect combined with ray optics. So there is a lens and there is a light source. There is this lens over here. So the rays of light will pass through that particular lens, and probably they are meeting somewhere, and somewhere in between you have a plate which gathers all that light, and then there is photoelectric effect, and you are able to measure the current because of the photoelectric effect. Now, if you use another lens having same diameter but different focal length, well, if you use a lens the same diameter, different focal length, what will happen? The rays, instead of converging here, will probably converge here. How does it make a difference? Same light, because the diameter is same, the aperture is the same, the opening is the same. Therefore, the intensity of the light is same. Therefore, the current will be the same. Remember, in photoelectric effect, current depends on intensity of light, and that is the same. So hence it won't matter. Answer is D. This was such a brilliant question. Many people thought it depends on the focal length, but no, it depends only on the how much light is being allowed, and that depends on the opening of that lens, which is the diameter of the lens. A very different kind of question. Moving on to the next one. Refractive index is given. Ratio of the minimum deviation to angle of prism is 1. That means delta m by a is 1. They might as well tell us that delta m is a. Okay. Value of the angle of prism. Guys, there is only one formula which will help us, and that is mu is equal to sine of a plus delta m by 2 by sine of a by 2. So mu is basically root 3. This will become sine of a plus delta m. Delta m is also a. So it will become a plus a divided by 2 divided by sine of a by 2. Take it on the other side. So root 3 times sine of a by 2 is equal to 2 by 2 is 1. So sine a. So this will just become sine of a. I have an idea. Why not do this? Root 3 sine of a by 2. I'm thinking of double angle formula. Write it as 2 times of sine of a by 2 into cos of a by 2. That is the simple manipulation which anybody should be able to think of, because then I can cancel sine a by 2 on both sides. So root 3 by 2, 2 goes below, is nothing but cos of a by 2. That means a by 2, whose cos is root 3 by 2, it is basically 30 degrees. So therefore, a is basically 60 degrees. That is the correct answer. So angle of prism is how much? 60 degrees, which is perfectly correct. So little bit of trigonometry definitely is involved in ray optics, and you should be well aware of it. A ray of light falls on a slab, refractive index, at an angle equal to the critical angle, lateral displacement. Wow, we have everything combined over here. But first, let's find the angle of incidence, which is equal to the critical angle. To find the critical angle, let's use this formula. Sine of IC is 1 by mu. Mu is 1 by root 2. So therefore, the critical angle is 45 degree. Sine 45 is 1 by root 2. Therefore, the angle of incidence is also 45 degree. So one might easily think, sir, then the ray will get internally reflected. True, if it was incident in the denser medium. But this is from the rarer medium. Remember, if this is the glass slab, the ray is not incident from inside the slab, it is incident on the slab, like this. So understand that. So this angle is what is given to be I. So the ray will simply refract and again refract. And the question is, how much is this lateral shift? That is the question. Is that okay? How much is the lateral shift? All right, to find that, we need one more thing, which is the angle of refraction. So let's use Snell's law. So sine of I by sine of R is basically mu. So sine of I, which is 45, upon sine of R is mu. Mu is basically root 2. So sine of R will be sine 45 divided by root 2, which is 1 by root 2 into 1 by root 2, which is 1 by 2, whose sine is half, obviously 30 degrees. So I and R I know. So to find that lateral shift, use this formula T into sine of I minus R divided by cos of R. Thickness is 4 root 3 sine of 45 minus 30. How? 45 minus 30, I minus R, whole thing divided by cos of R. R is basically 30. Okay, so 4 root 3, 45 minus 30 is 15, sine 15 is 0.25. So sine 15 is 0.25. Cos 30 is root 3 by 2. Root 3 cancels. 0.25 into 4 is 1. So 1 by 1 by 2, which is basically 2. So answer is 2. Yes, that is perfect. So concept of internal reflection, Snell's law, and lateral shift. Three things in one. One of the really good questions, guys, which was asked in JEE Mains 2024. What an amazing thing. Moving on to the next one on your screen. What does it say? Distance between object and its 3 times magnified virtual image by a lens is 20. Focal length used is how much? All right. So clearly, magnification is how many times? 3 times. Magnification for a lens is V by U. And since it is virtual image for a lens, the magnification, because it is erect, it will be basically, because the image and the object will be on the same side, so the V by U ratio will be positive, so it will be +3. This is positive because it is a virtual image. This is basically because it is a virtual image. Okay, so therefore V is basically 3 times of U. That is number one. Second thing, the distance between object and its image is 20. So image coordinate minus object coordinate is basically 20 units, but this is 3U. Therefore 2U is basically 20. Therefore U is basically 10. But this will be the magnitude of it. So actually speaking, U will be -10. U will be negative because object will be negative. Similarly, if you find V, if you try to find V, V will be 3 times of U. U is basically -10. So this will be -30. Now try to find, what do you say? Focal length using lens formula. 1 by V minus 1 by U is equal to 1 by F. So 1 by -30 minus 1 by -10 is equal to 1 by F. So minus minus is plus, so it will become 1 by 10 minus 1 by 30 is equal to 1 by F. LCM is 30, so it will become 3 times minus 1 is 1 by F. 3 minus 1 is 2, so 2 by 30 is 1 by 15 is 1 by F. Reciprocal, it will be 15. So focal length is 15 centimeters, which is correct, and definitely. Cool, guys. So hope you are able to catch up. Any mistakes you are making, try to learn. Next one on your screen. Light from a point source falls on a convex curved surface. Radius is given, refractive index is given, source is away by some distance. Where will it be formed? So as per this particular question, there is a curved surface. Let's say this is the principal axis. You have a source of light which is 100 centimeters away, which we can treat it like the object. Now radius of curvature 20 centimeters. So this is given to be 20 centimeters, and this side is basically air. So refractive index is 1, and this side is made of some medium. So refractive index is 1.5. The only thing I can think of is the curved surface refraction formula, which goes like this: mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Mu2 is the refracted side refractive index, which is 1.5. Mu1 is the incident side refractive index, which is 1. So same order will follow. So 1.5 minus 1. Image, I don't know. Object, left side, so -100. Radius on that side, which is positive, so +20. That's it. 1.5 is 3 by 2. Minus minus plus goes on the other side as negative, so -1 by 100. 1.5 minus 1, 0.5. 0.5 is half. Half into 1 by 20 is 1 by 40. LCM, what is it? 40 and 100 is 200. So it goes 5 times. This will go 2 times. So it is the same as 3 by 200. Uh, 3 3 cancels, 2 2 cancels. So 1 by V will be 1 by 100. So V will be 100. So that means the image will be formed over here at a distance of 100. So the question is, image will be formed at how many centimeters from the object? This is 100, this is 100. Total will be 200. Answer should be 200 centimeters. Yes, it is correct. So curved surface refraction question was there. All right. Moving on to the next one. A graph is given and distances are measured with reference to the focal point. What is the focal length? You know what is this question based on? A lot of you might think, sir, shall I use lens formula? No. For these lenses, when it is measured with respect to not principal, not optical center, but focal point, then the formula which you use is Newton's formula. Newton's formula, which is object distance into image distance is focal length square. That's it. Now, out of all these points A, B, C, D, and E, only one coordinate you know, which is of C, which is this one. B's coordinate you do not know exactly. Somewhere in between it is. Even A's you don't know. D also you don't know. E also you don't know. So C is the only one which you know. So X is 20. Y is also 20. So that is F square. So basically F will be 20. That is the answer. Yes, it is. It was such a simple thing. But if you know this formula and you understand that none other coordinates you know exactly, the only one you know is option C, or the point C's coordinates. What a brilliant, brilliant question, guys. Okay, so you should be aware of it. Distance between object and its two times. You can see this pattern of question is getting repeated so many times. Magnification given, image object distance. Very important, which means object and its two times magnified real image. So the magnification is basically two times produced by a lens. So magnification formula for a lens is V by U. Now whether it is plus or minus, look at it. It is given to be real image. The moment it is real, this should be negative 2. Understand that? Reason being, real means it will be on the other side. So the image will be inverted. Image will be inverted. That is why it will be negative. Real means it will be inverted for that lens. So therefore, V will be, what is it? Minus 2u, I believe. And one more thing which is given to me, object and the image distance is 45. So V minus U is basically 45. V minus U is basically given to be 45 centimeters. Perfect. So V is minus 2U. So use that. Minus U is basically 45. So therefore minus 3U is 45. So therefore U is how much? Minus 15 centimeters. From this, we will get V is equal to minus 2 into minus 15, which is plus 30 centimeters. So that is the value of V. Now we are just supposed to use lens formula to find the focal length. So 1 by V minus 1 by U is equal to 1 by F. V is basically 30. U is basically negative 15. So that is 1 by F. So 1 by F will be minus minus is plus, LCM of 30 and 15. So that's 30. So 1 plus 2, which is 3. 3 by 30 is 1 by 10 is 1 by F. So F is basically 10. Perfect. So the answer is 10 centimeters. Perfect. Got it. Awesome. What a question, guys. Moving on to the next question on your screen. Two liquids which cannot mix as shown. Coin is kept at the bottom. Height of each layer is this. How much is the apparent depth? If it is alpha by 4, what is alpha? So usually the formula of apparent depth is the actual depth by the refractive index if there is only one layer. But if there are multiple layers, then it will be h by mu, h by mu, h by mu. You keep on adding it depending on the layers, but this will be h1, h2, h3, mu1, mu2, mu3, respective indices, respective thicknesses. in this particular question, I just have to deal with only two layers. So height 1, 6, mu 1, 8 by 5. Height 2 again 6, refractive index 3 by 2. That's it. So 6 and 8 goes 3 by 4 times, and this will go 5 times, plus 6 goes with 3 2 times. That 2 will again multiply over here. So that is 15 by 4 plus 4, which is 15 plus 16 by 4, which is 31 by 4. 31 by 4, so alpha should be 31. Yep, it is 31. Perfect, got it. So this is the formula when you have multiple layers or slabs and you want to find the net apparent depth. So always remember the apparent depth is measured from the topmost point. From the topmost layer, this is what that apparent depth will be. Okay, so there will be some shift which will be produced. That shift will be from here to here. This is the shift. This is the shift which will be produced. Okay, understand the difference. Perfect. Moving on. So we have come to the end of the class, which means we have solved all the questions of ray optics from JEE 2024. So hats off to you if you stuck around till the end. Number two, this is not the end because you have to solve more questions. Obviously, the best boon for any JEE aspirant is that you have so many shifts, so many papers that even if you practice this, it will be a good level of preparation to the actual examination level. So I'm giving you all the shifts, all the papers, all the questions of 2022 and 2023 because we have done 2024, and with the detailed solutions along with all the questions organized in a systematic way chapter wise. You pick any chapter, all the questions of 2022 and 2023 are organized chapter wise, unit wise for all the three subjects, and it includes both integer type as well as your numerical, sorry, as well as your single correct options. All these questions of 2022 and 2023 are more than 1300 questions, which is a very good collection, and I would suggest you to use the hard copy because when you're already on the computer for a long time, your eyes might get affected. So use the hard copy. You can take that book anywhere and you can get the real feel of practice, right? So you can practice it on the book. Solutions are available, and to buy this book, the link is there in the description box below. Over here, just click on this particular link. It will open this particular Vedantu store page. You can see you will get it couriered as soon as possible. All the questions, detailed solutions with ready to practice questions, guys, without missing anything. Get it delivered, add to your cart, or click on buy now. That's all right, very straightforward. So make use of this book along with your series for 2024. And if you have watched the entire lecture, make sure that you are putting this comment, Ray Optics 2024 done, because you're done with it. You should be happy about it. Go ahead now and practice 2022 and 2023. Okay, all the best. More series, sorry, more videos from this particular series is going to come, so stay tuned by subscribing to the Vedantu J English, and give your Guru Dakshina by liking this video. Okay, bye bye guys, take care. Captain Shreyas signing off. Hasta la vista.